Hey, you guys. Sorry I couldn't be there with you today. I have a sick little baby at home, and so I'm going to take time with him. But I did have some opportunity to take and finish up the notes for you guys and then leave you with a worksheet of plenty of problems of the same type so that you can kind of get the hang of this Taylor polynomial thing. I'll also post some hints on how to tackle that worksheet. Maybe just go through and do a few of them here and there just to kind of get you going. Ideally, I want that whole thing finished for Monday, which means we have some time tomorrow to tackle a little bit of it, what we don't finish today. But do take as big a chunk out as you can, work on it tonight. Any questions, you can always email me. So this fourth, I think we finished here yesterday. We were talking about, it was example 4. And we went through and took all the derivatives. We're doing 6 of those, so n equals 6. And what I've got now is, let's see, I didn't put them all in there. Let's just do a quick run through. I think I stopped shy of it. Here's just the general stuff. We took, if you remember, what you do is evaluate at the center. So center is 1 in this case. So you take each of those derivatives and the function. Did you know like the 0th derivative, like the first derivative is what we know of as, the first derivative. The 0th derivative is like not taking the derivative is actually the original function. So this all falls into place. That first term then is going to be, in this case, it's going to be 0, because we're going to put 0 times x minus 1 over 0 factorial. Remember, 0 factorial is 1. And then you fill in the rest of the terms according to the lovely Taylor polynomial form. So here we go. And I stopped at third degree just because I know we did this yesterday, but that's a recap of yesterday. And what we used that for is we took that Taylor polynomial, the approximation of log of x. And it's important to note that's an approximation. And we used it to evaluate something close to 1, the center of our function. We did 1.1, found out it was pretty darn good. So the next piece was then we took these values. So what we've got then is this polynomial where what we can do is the coefficient out here, this piece, this is always that 3 in this case, is the first one's going to be the function with the center plugged in, so in this case 3. Then the second term is going to end up being the negative 4 that we got from g prime of 2 that you see over here, times x minus center to the first power over 1 factorial, which I'm not writing in there, so you're welcome to put those in here. Those are all things you can add if you like. Then the next term is 7, the g double prime, the second derivative, which is 7 times x minus the center to the second power. I put in the center as 1, didn't I? Anyway, the center is 2, so I'm going to change those to 2 here in a second. So hang on, I'll go back and fix that. So x minus should be 2 to the second, all over 2 factorial. And then you have 5, the minus 5, because the third derivative is negative 2, with 2 plugged in is negative 5. Times x minus 2 to the third factorial over 3 factorial. So just knowing the value of the function and its derivatives at the center allows you to get that first coefficient piece that you put into the Taylor polynomial. The x minus center to the appropriate exponent over the factorial that matches the exponent. Have you noticed that always happens? The exponent and the factorial number always match. That's important to note. So that's your basic Taylor polynomial, third degree, centered at 2, now that I fixed that. So let's keep rolling. Example 6. So we didn't get quite here. Some of you may have tried it. Hey, check out these derivatives. Awesome. E to the x is always the best. So anyway, you get a bunch of e to the x functions. Derivatives are all the same. You put in 0, the center. Remember what we call that? Centered at 0? The Maclaurin series. Cullen Maclaurin. If you haven't noticed, some of our kids have a bunch of Irish names. We have absolutely no Irish heritage whatsoever, but we really like Irish names. We got Nora, Kieran, Neil, myself, and we have Ethan. He's another good Irish name. And then we put in one kind of wild card, little Graham here, who happens to be in my arms as we speak. Maybe I should put him up to the microphone. Can you hear his breathing? Yeah, we can. Maybe I'll make some squawks here in a minute. Anyhow, the third degree Taylor approximation for this means we're going to take 3 derivatives. We're going to write out the polynomial. Remember, this is approximating e to the x. The crazy thing is, it approximates e to the x anywhere around the center. It actually gets the exact value at the center point at 0 for e to the x. So at e to the 0, we'll get 0, or we get 1. for this polynomial, when we put in 0, we will get 1. So it's exact at the point of center, but anywhere around it, it's an approximation, and a pretty darn good one, depending on what degree of derivative you take outside of in that polynomial. So anyway, here's a quick run through those. We're centered at 0. At first I put x minus 0, and then after that I just took those off and said, I figure you got the point. So this is our third degree Taylor polynomial. Again, let me know if you have questions about that. So it should be x, because the x minus 0 is just x squared over 2 factorial, x cubed over 3 factorial. Pretty nice, or approximation of e to the x is a very nice polynomial, nice pattern to it. It's one you want to actually tuck away to memorize later on. I'll have a list to give you guys here tomorrow or Monday, one of those days, of Taylor polynomials you should have in your back pocket. But there it is, third degree Taylor polynomial for e to the x. Now, let's see. If we do the limit of e to the x and we approximate it, you can actually approximate other functions with e to the x in them by substituting in various degrees of the Taylor polynomial representing that function. So that's what I'm doing. Instead of e to the x, I'm going to use that third degree Taylor polynomial. And from there, I don't know why that weird red mark is in there, but I must have touched it with my pen. If I actually look at it, the ones cancel, and if I factor out an x, what I get is those x canceling. And if I run the limit, you'll notice that I get 1 over 2. And you can actually use L'Hopital's rule there too, because it is 0 over 0, and you can do a derivative. Whatever floats your boat, that works as well. So remember, L'Hopital is very powerful. If you have 0 over 0 over infinity, just take the derivative of the top, derivative of the bottom, and run the limit of the result. In fact, hey, let's do that for the real e to the x. So remember on the right here, we just did the approximation of the limit with using the Taylor polynomial instead of e to the x. Well, now if I take the actual limit, and then notice, yes, if I put in 0, I get 0 over 0. If I take the derivative, do good old L'Hopital, I get e to the x over 2. Throw in 0 by direct substitution, I get 1/2. Hey, for both the approximation at 0 of the limit and the limit itself at 0, the original function, I get the same thing. Is that surprising? Well, maybe it does, maybe it doesn't. It shouldn't, because Taylor polynomials are exact at the point of center. They approximate outside of that. And that should be about the end of the story. El mismo, and that's good, at the point of center. Hey, you guys have some problems to work through that are similar, maybe a little stretch on what you know. Do as much as you can, and let me know how I can help. Sorry I couldn't be there with you. I always enjoy our time together. I'm going to hang with this baby, get him back up to health. See you guys.